All right, so I figured the thing that people are going to have the most trouble with is converting to vertex form. So I'm going to do this a couple times just for fun. So first thing I'll do, other than get my pen ready, is I'll do the first one by kind of in the purest method. So I'm going to subtract 13 from both sides. And I'm going to get y minus 13 then I'm going to take half of 12. Oh, I forgot the 2x. The next thing I'm going to do is divide everything by 2. And so then I get this fun thing on the left here that I'm not really going to do much with. I'm just leaving it there to kind of placehold those processes that I'm going to need to do later on. Now I'm going to take half of 6, which is 3, and then I'm going to square it, and so I'm going to add that to both sides of the equation. And so then I still have an even nicer mess over here, but I'm just holding those functions for later. Now what I'm going to do, so that I have room, I'm just going to put a little line here, and I'm just going to write that left side down one more time, and I'm going to rewrite this as a perfect square. So it's going to be x minus 3 squared. Now I'm going to start solving for y. So I'm going to uncover all these different functions, and I'm going to start by subtracting 9 from both sides. And then I'll get y minus 13 over 2 equals x minus 3 squared minus 9. Now I'm going to multiply everything by 2. And I mean everything. So then I'll have y minus 13, because those just kind of cancel out. And then I'll have 2 times x minus 3 squared minus 18, because I distributed this into both parts. Now I'm going to add 13 to both sides, and I'll have y equals 2 times x minus 3 squared minus 5. And now I'm in vertex form. My x-coordinate is positive 3, my y-coordinate is negative 5, and I have a vertical stretch of 2. Alright, let's do it again. This time, I'm going to do the scooch method. Okay, so I've got, I'm just going to use y for now, and then I'll put the g of x in at the end. So I've got 3x squared, and I'm going to start by just scooting this over here. Okay. Then I'm going to factor out the 3 out of both of these. And then I'm going to add half of b squared. So half of 10 is 5. 5 squared is 25. Now, but when I've actually added 75 to this equation, if I distributed this back in, that would be 75, right? So I've added 75, so I'm going to subtract 75. And I get minus 1 right there. Then I rewrite this as a perfect square, and I get x plus 5 squared minus 1. Now, and you can see, and so then I'll rewrite it back with the g of x, just so it's all the same. And you can see that we have that was kind of a lot fewer steps. But once again, whatever floats your boat. And this idea of seeing that 3 times this number and then you subtract that, that's often quite tricky for people. let's try one more example here. And I'll do this one in both methods. So we'll start with the purest method. Hopefully I can fit it all in here. So I'll subtract 2. Then I'll divide everything by -3. So that's going to be x squared minus 2x. And then I'm going to add 1 to both sides. And I'll go ahead and write this as a perfect square. And then I can start working all this back apart. Go ahead and start up here. So the first thing I'm going to do is subtract 1. Then I'm going to multiply everything by -3. And so then I get y minus 2 equals -3 x minus 1 squared plus 3, right? Because if I distribute this in to both of those, then I'm going to add 2 to both sides, and I will get y equals -3 x minus 1 squared plus 5. So then my vertex is +1, +5, and I have a vertical stretch of -3. I'll write it back with f of x notation. All right, so now let's take a minute and I'll do it the other method, the scooch method here. Let me just write this down again so I can start over. I'm going to scoot this down a little bit. Oops. All right, so with the scooch method, my first step is just to scooch. Then I'm going to factor. Then I'm going to add 1 inside. -3 times 1 is -3, so I added -3 to this side of the equation. So I'm going to add +3 to the other side of the equation. And then I will rewrite as a perfect square. And now you can see that we have both of these equations are the same. And then we can start graphing. All right, well, hopefully seeing a couple more examples was helpful.